The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today, we're going to start chapter 10. And we'll be taking a look at section 10.1, and we'll be looking at what is known as the square root property. All right, so let's take a look. Let's say that we have 3 squared. 3 squared equals 9. Let's say we have -3, the quantity squared. -3, the quantity squared equals 9. Let's say we have the equation x squared equals 9. Can you see that x could equal -3 or x could equal +3? Because -3 squared is 9 and +3 squared is 9. How we arrive at that is we can do the following. Well, let me backtrack for just a minute. In the last chapter, we had equations with radicals, square roots, cube roots, fourth roots, and we squared or cubed or raised both sides to the 4th power to get rid of the radicals. Here we're kind of going in the other direction. We're going to take the square root of both sides. And what we need to do, we need to have the problem in the form that this problem is in, where on one side of the equation there is a square, and on the other side of the equation, there is just a constant. So no variables on, we'll say, the right side. What I'm going to do now is take the square root of both sides, which gives me this. However, if we go back to the previous page, we see that this had 2 solutions. So in fact, when we take the square root of both sides, we put a little plus minus in front of the radical on the right, which then gives us 2 solutions. X is ±3, and that's how we say it. Now, in the mathematical world, this is an acceptable shortcut notation. So instead of saying x equals -3, x equals 3, you could write it this way. However, WebAssign does not have this notation. So in WebAssign, you would list the 2 solutions separated by a comma. And I'll say more about that as we progress. But we do have 2 solutions to this equation. Any questions before we go on? All right. Let's see here. Here we have an equation, w squared minus 47 equals 0. So the first thing we're going to do is isolate the square. I will do that by adding 47 to, whoops, that's a fine looking W, by adding 47 to both sides of the equation. Now, using the square root property, I will take the square root of both sides of the equation and apply the plus or minus. So I get W equals plus or minus the square root of 47. Now, I can't simplify the square root of 47. There are no perfect square factors in there. I'm not going to go with a decimal approximation. I'm just going to leave the exact answers. In WebAssign, I would list it as negative the square root of 47, comma, the square root of 47. Now, I want to point out a couple of things that will give you troubles if you don't do it correctly. I don't know whether putting the plus sign in front of it is going to mess things up or not, but you don't really need the plus sign. But the thing you've got to be careful of is this comma, okay? If you're not really careful in WebAssign, let's say you do this, and then you don't get out of the radical, but you put a comma in there, it will think that the comma is inside and part of the radical. So what I'll see is a student will write this, and WebAssign will say it's incorrect, whereas the thing they needed to do was just move that comma outside of the radical, okay? So be careful of that. Also, you'll need to simplify as much as you can. This problem doesn't simplify. We'll see more on that coming up shortly. Okay, how about this one? X squared minus 101 equals 0. So again, I'm going to get it in that form where on one side of the equation, typically the left side, will have a perfect square, and on the right side there will be a constant. Then we'll take the square root of both sides, applying the plus or minus. 101 turns out is prime. It doesn't have any, I don't think there's any factors. Well, actually, I'm not 100% sure it's prime, but I know it doesn't simplify further. So our answers would be negative the square root of 101, comma, the square root of 101. All righty. Let's take a look at this next one. U squared minus 24 equals 0. Okay. So I'm going to isolate the perfect square first by adding 24 to both sides of the equation. Then I will apply the square root property and take the square root of both sides, also applying the plus or minus to the right side. So I get u equals plus or minus the square root of 24. However, the square root of 24 can be simplified, so we are expected to do that. Let's see, that would be 24 is 4 times 6. 4 is a perfect square. 6 breaks down to 2 times 3, so there's no perfect squares there. But then this would become 2 square roots of 6. Okay, so then u equals plus or minus 2 square roots of 6. So that would be the answers. And in WebAssign, you would put in negative 2 square roots of 6, comma, 2 square roots of 6. And again, make sure, in this case, the 2 is not the index. It's a constant multiplier or a coefficient, if you want to think of it, outside of the radical. So those would be your 2 solutions. Any questions? All right.
Is this always plus and minus? Will you ever arrive at just a negative or just a positive answer?
In this context, you will get 2 solutions. Okay?
Perfect, thank you.
Yeah, in this context. That's the trick there. Okay, let's take a look at this problem. X minus 1, the quantity squared, equals 4. We still have a perfect square on the left side of the equation. We have a quantity with a variable inside squared equal to a constant on the right side. All right, so now we'll take the square root of both sides of the equation. On the left side, we get x minus 1. On the right side, we get plus or minus 2, because the square root of 4 is 2. But we're trying to solve for x, so we're not done yet. We need to add 1 to both sides of the equation. I'm going to put that 1 in front, so I have x equals 1 plus or minus 2. But I'm going to take that out into its 2 specific solutions. So x equals 1 plus 2 would be 3. X equals 1 minus 2 would be negative 1. So the solutions would be negative 1 and 3. Okay. Any questions there? All righty. Let's take a look at another one of those. Let's see here. S minus 7, the quantity squared, equals 9. Once again, I have a perfect square containing a variable on the left side of the equation and a constant on the right side of the equation. I will take the square root of both sides of the equation, which gives me s minus 7 equals plus or minus 3. I'm going to add 7 to both sides. So s equals 7 plus or minus 3. So s is 7 plus 3, which is 10, and s is 7 minus 3, which is 4. So s equals 10 and 4. Now, it doesn't always do this, but be sure to read the directions carefully on WebAssign, because sometimes it will say to put the smaller solution first. In this case, it would be the 4. It doesn't always say that, but just be careful for little things like that. Okay, let's see here. This one says, let f of x equal the quantity x plus 5 squared. Okay, then it says, for what value, and then or values of x is f of x equal to 3. So again, we're going to make a substitution. We're going to put this in the place of that. So our equation becomes that, replacing f of x with 3. So now I'll take the square root of the left side and the square root of the right side, and I get x plus 5 equals plus or minus the square root of 3. The square root of 3 is irrational. It can't be written exactly as a decimal. It can't be simplified. So we'll leave it as the square root of 3. Okay. I'm going to subtract 5 from both sides. So I'm going to get x equals negative 5 plus or minus the square root of 3. And again, that's acceptable notation, but we can't use that in WebAssign. So in WebAssign, we'd have x equals negative 5 plus the square root of 3, comma, negative 5 minus the square root of 3. Those would be the two solutions. And again, unless they ask for it, don't use decimal approximations. Any questions on that one? All righty. Let's see here. Okay. This one says, let g of a equal the quantity 7a minus 2 squared. Then it says, for what value or values of a is g of a equal to 8. All right. So just like the last problem, that's a question mark there, we're going to put 8 in the place of g of a. So we'll get the following equation. 7a minus 2, the quantity squared, equals 8. Okay. Then we'll take the square root of both sides of the equation. On the left side, we get 7a minus 2. On the right side, we get plus or minus the square root of 8. Now, there are several things we need to do. We need to finish solving for a, but we're also going to need to simplify the square root of 8. We can do it in either order. I'm going to simplify the square root of 8 first. So I'm going to come up here and I'm going to say, well, the square root of 8 would be the square root of 4 times 2, which would be 2 square roots of 2. So this now becomes 7a minus 2 equals plus or minus 2 square roots of 2. Okay, so I've simplified the radical. All right, now, next I'm going to add 2 to both sides. So I'm going to get 7a equals 2 plus or minus 2 square roots of 2. Next, I'm going to divide both sides by 7. So I'll get a equals 2 plus or minus 2 square roots of 2 over 7. That's supposed to be a 7. It looks like a 2. Come on. Go. Now, let's see. My answers would be 2 plus 2 square roots of 2 over 7 and 2 minus 2 square roots of 2 all over 7. And again, those separated by a comma. Any questions about that one? Okay, you're probably going to be terribly disappointed, but that's all I have for you this morning. So in section 10.1, there are some other things, but we don't deal with them in Math 93. So you want to master this whole square root property. The thing that people tend to forget is to apply that plus or minus to the right side of the equation at the appropriate time. And if you forget it, then you've left off half of your solutions. And then in terms of WebAssign, to write them out separately, and again, separated by a comma that's outside of the radical. Do you have any questions before we go?
No, this is one of the easiest things. Thanks, Mr. Mayor.
You're welcome. I will be back at 1:15 if you have any other questions. Otherwise, have a great day, and